All right, so you're here because you want more than just those headlines on climate change, right? You want to really get what's going on.
Exactly. We're going deep, beyond the surface.
We've got a whole bunch of sources, science reports, opinions, even some positive stuff too. It's going to be interesting.
It's not just like, oh, it's getting hotter. It's way more than that.
Yeah.
We'll look at how this affects, well, everything. Glaciers melting, hurricanes getting stronger, the whole picture.
And we'll talk about how scientists can basically look back in time, like 800,000 years back, using ice cores. Crazy, right?
Yeah, it's amazing what those ice cores can tell us. We'll even uncover the differences between those gases that are causing climate change. Some act fast, some are in it for the long haul.
Sprinters versus marathon runners, huh?
Perfect analogy.
Okay, so first things first, climate change. We all hear about it, but what does it actually, mean? Like, how is it different from just the weather today?
Good question. Weather is what you see outside right now, right? Sunny, rainy, whatever. Climate is more like the average of that weather over a loon time, decades, centuries even.
So climate change is when that long-term average changes a lot.
Exactly. And sure, global warming is a big part of it, but it's not just about things getting hotter. Global warming sets off a ton of other changes. Those glaciers melting, sea levels rising, those crazy weather events we keep seeing.
It's like a chain reaction.
It is. It's a whole interconnected system. And those ice cores you mentioned. One way we know how much things are changing.
Yeah, that 800,000 years worth of data is just mind-blowing. How do they get that from ice?
So imagine Antarctica. Snow falls, gets compressed over time, turns into these layers of ice, right?
Right, I get that part.
But as those layers build up, tiny air bubbles get trapped inside. Ancient air. Scientists drill deep down, get those bubbles, and analyze them.
Like a tiny time capsule frozen in the ice.
That's it. They can see past temperatures, greenhouse gas levels, even when volcanoes erupted. It's pretty clear the Earth's climate has always changed, but the speed of what's happening now, we've never seen anything like it.
So what's causing that rapid change? Greenhouse effect, everyone's heard of it, but can we break it down? What's really happening up there in the atmosphere?
Think of it like this. Earth's wrapped in a blanket,
Sure.
right? That's the atmosphere. Certain gases act like the threads of that blanket, trapping heat from the sun.
That's the greenhouse effect.
Right. And it's a good thing, actually. Keeps the planet warm enough for life. Without it, we'd be a giant snowball.
So what's the problem? Too many blankets.
Pretty much. Human activities are pumping out way more of these heat-trapping gases, so the blanket gets thicker and the planet warms up way faster than it should.
Okay, so time to name names. Our sources talk about a few main culprits: carbon dioxide, methane, nitrous oxide, and these things called fluorinated gases. What are those even coming from?
Well, that carbon dioxide, CO2, that's the biggest one, mostly from burning fossil fuels like coal, oil, and gas.
Cars, power plants, all that.
Exactly. Then there's methane. Powerful stuff. Comes from livestock, like cows, and also from growing rice. And don't forget, leaks from natural gas production.
Methane. That's the one that's super strong but doesn't last as long, right?
You got it, like a quick burst of heat compared to the CO2, which kind of hangs around.
Okay, then what about nitrous oxide? And those fluorinated gases, what are those all about?
Nitrous oxide mostly comes from fertilizers and some industrial processes. And those fluorinated gases, those are man-made, used in refrigerators, air conditioners, things like that.
So we're kind of surrounding ourselves with these gases everywhere we go.
Pretty much. But it's not just what we're putting into the atmosphere, it's also what we're taking away. Deforestation is a big factor here.
Yeah, trees. Those are the lungs of the planet, right? They give us oxygen.
Yeah.
But what's the connection to climate change?
Trees are actually amazing carbon sinks. They suck CO2 right out of the air when they do photosynthesis. So they're like a natural way to regulate the Earth's temperature.
So when we cut them down.
We lose those carbon-absorbing powerhouses. And even worse, when trees decompose or are burned, all that stored carbon goes right back into the atmosphere.
A double whammy. And this deforestation isn't just happening on a small scale, is it?
No, it's a huge problem, especially in places like the Amazon rainforests. You know, they call it the lungs of the Earth for a reason. But if we keep cutting it down at this rate, well, there's a chance the Amazon could actually start emitting carbon instead of absorbing it.
That's a scary thought. The lungs of the Earth turning against us. Okay, so we've got these greenhouse gases piling up, and we're cutting down the things that help absorb them. But warmer temperatures, that's just the beginning, right? What else are we looking at?
Yeah, that's just the tip of the iceberg. The effects of climate change go way beyond a few extra degrees on the thermometer.
Okay, like what? Give us the rundown.
Well, one of the biggest things is those massive ice sheets and glaciers melting. That adds to rising sea levels. And we're talking about the huge ones like in Antarctica and Greenland.
How huge are we talking?
Huge enough that if they all melted, sea levels could rise by meters. Meters.
Meters. Okay, that's terrifying. But how fast is this actually happening?
Well, get this. The Arctic is warming almost 4 times faster than the rest of the planet. It's alarming, really, not just for ice melt and sea level rise, but it messes with global weather patterns, too. Even the jet stream gets messed up.
So it's not just about coastal areas being flooded.
Nope, it affects weather all over the place. These changes in the Arctic trigger these chain reactions, leading to more extreme weather events. Heat waves, droughts, those really heavy rainfalls.
Yeah, those crazy weather events. Our sources talk about hurricanes getting stronger, droughts lasting longer, and way worse flooding. It's like the weather is going on steroids.
That's one way to put it, and the data backs it up. Studies show that hurricanes are about 10% wetter now than they were just a few decades ago.
10% more rain. Whoa.
Imagine that. The risk of really bad flooding when those hurricanes hit is way higher.
And it's not just us humans feeling the heat. What about all the other life on Earth? Plants, animals, the whole ecosystem.
Climate change is a huge threat to biodiversity. As temperatures rise and habitats change, a lot of species just can't adapt fast enough. And that means extinction.
I always think about those coral reefs. They're so sensitive to changes in the ocean.
Yeah, coral reefs are a prime example. Ocean warming and acidification, it's hitting them hard.
I've seen pictures of those coral bleaching events. It's sad. They're like these underwater cities full of life, and they're just dying off.
Yeah, it's devastating. The Great Barrier Reef, for example, it's already suffered multiple bleaching events. And scientists are warning us. Without serious action, the damage could be irreversible.
And coral reefs aren't just pretty to look at. They're a whole ecosystem.
Right. They support about 25% of all marine life. It's a big deal.
Wow. So we've got the oceans, the land, and we can't forget about the direct impact on us humans, right? Those heat waves are getting worse, and that's a serious health risk, especially for older folks and people who are already vulnerable.
Absolutely. And climate change is messing with how diseases spread, too. Warmer temperatures let disease-carrying insects, like mosquitoes, spread out to new areas. So the risk of things like malaria and dengue fever goes up.
And then there's, the less obvious impacts, like food and water. When droughts get more frequent and severe, it throws agriculture out of whack. That means food shortages, prices going up, and clean water gets harder to find in a lot of places.
You're right. Climate change kind of makes existing problems even worse. It creates new challenges all over the world.
All right, this is getting pretty heavy. We've got rising temperatures, melting ice, crazy weather, threats to all kinds of life, and it's directly affecting our health and well-being. Is there more?
I'm afraid so.
Mhm.
We need to talk about these things called feedback loops. They're crucial to understanding the whole picture of climate change.
Feedback loops. Okay, hit me with it.
Think of them like domino effects in the climate system. When one part of the system changes, it can trigger other changes. And those changes can either make the problem worse or, in some cases, maybe a little better. Those are called positive and negative feedback loops.
Okay, I'm intrigued. Can you give me an example?
Sure. A classic example of a positive feedback loop is the albedo effect. Albedo is basically how reflective a surface is. So ice and snow, they're very reflective, right? They bounce a lot of sunlight back into space.
Right, that's why you got to wear sunglasses even when it's cloudy out on the snow.
Exactly. But when ice and snow melt, it exposes darker surfaces underneath, like ocean water or bare ground. And those darker surfaces absorb more heat.
So less ice means more heat absorbed, which leads to even more melting.
You got it. A vicious cycle.
Okay, that makes sense. What about those negative feedback loops you mentioned? Are there any processes out there that could actually slow down climate change?
There are a few natural processes that can act as brakes, but there are some catches too. One is carbon sequestration. That's basically capturing and storing carbon from the atmosphere.
And trees and oceans do that, right?
They do. Forests and oceans are major carbon sinks. They suck up CO2 from the air.
So trees and oceans to the rescue.
Well, it helps, but it's not a complete solution. Those natural carbon sinks have limits, and climate change itself can actually make them less effective.
How so?
For example, as oceans get warmer, they actually get worse at absorbing CO2. It's another one of those pesky feedback loops.
Right, those feedback loops always seem to come back to bite us. Any other negative feedback loops that offer a glimmer of hope?
Well, there's increased vegetation growth. In some areas, having more CO2 in the air can actually make plants grow faster. Plants need CO2 for photosynthesis, so more CO2 can mean more plant growth, which in turn means they absorb more CO2.
So a bit of a silver lining there.
It's not that straightforward, though. While more CO2 can help sometimes, it's not a cure-all. Things like water availability, nutrients, and temperature, those all play a role too. And there's a limit to how much CO2 plants can absorb.
Right, we can't just rely on plants to magically fix everything.
Uh,
Okay, so this has been quite a deep dive into the science of climate change. It's a lot to take in, but I feel like I'm getting a much better understanding.
It's a complex issue, for sure. But like you said, knowledge is power.
Right. So, knowing all this, what's being done to actually tackle this challenge? What can we do about it?
That's the million-dollar question. And thankfully, there are a lot of people out there working on solutions. There are definitely reasons to be hopeful. It's not all doom and gloom, I promise. There's actually some really cool stuff happening, both on a global scale and things that individuals can do.
Okay, that's good to hear. Let's start big picture. What kind of global efforts are out there?
But one major development is this thing called the Paris Agreement. It's an international treaty adopted back in 2015.
I've heard of that.
Basically, it's a huge deal because almost every country in the world signed on, and they all agreed to take action to limit global warming. The goal is to keep it well below 2 degrees Celsius above pre-industrial levels, ideally aiming for 1.5 degrees.
Okay, so how does that actually work? Do countries, have specific targets they have to meet?
Yep, each country sets its own emission reduction targets. They're called nationally determined contributions, or NDCs for short.
NDCs, got it.
And the agreement has this built-in mechanism for countries to kind of, step up their game over time. So the goal is to keep getting more ambitious with those commitments.
So it's not just a one-time promise, it's an ongoing process. I like that. But how do we actually achieve those emissions reductions? It just seems like such a massive undertaking.
It's definitely a huge challenge, but there's this growing focus on moving away from fossil fuels and embracing renewable energy sources.
Yes. Renewable energy. That's what gets me excited. Solar, wind, hydro. They've come such a long way in recent years. And I love how they're becoming more and more cost competitive with those dirty fossil fuels.
Absolutely. I mean, the cost of solar panels has dropped by like over 80% since 2010.
80%? Seriously? That's insane.
It is. That makes solar energy one of the cheapest sources of electricity in many parts of the world now.
That's amazing. And what about batteries? I keep hearing about all these improvements in battery technology. That would help solve the problem of solar and wind power not being available all the time, right?
You're exactly right. Advancements in energy storage are super important. That's what's going to make renewables more reliable and help us really scale them up.
That makes sense.
But it's not just about replacing fossil fuels. There are also these other innovations in things like carbon capture and storage. These technologies could help us deal with emissions that are tougher to get rid of completely.
Carbon capture, that sounds kind of futuristic. How does that even work?
Imagine a giant air filter, but for carbon dioxide. That's basically what carbon capture is. It grabs CO2 emissions from places like power plants and factories before they can escape into the atmosphere.
Okay, so we're capturing the CO2. Then what?
Then it can be stored underground in these special geological formations, or it can even be used in certain industrial processes.
So we're basically cleaning up the emissions after they've been created.
Interesting. What about geoengineering? I've heard that thrown around as a potential solution, but it always sounds a little, I don't know, sci-fi to me.
Geoengineering is definitely more controversial. It's about doing these large-scale interventions in the Earth's climate system to try and, counteract warming. Some of the ideas out there include spraying aerosols into the stratosphere to reflect sunlight away from the Earth.
So basically blocking out the sun.
In a way, yeah. Another idea is fertilizing the oceans with iron. That would stimulate the growth of phytoplankton, these tiny plants that absorb CO2. Okay, those ideas do sound like something out of a movie. But I guess if the situation is dire enough, are there any downsides to those approaches?
The thing is, we have to be super careful with geoengineering. There are a lot of potential risks and unintended consequences, and we don't fully understand them yet. So while research is happening, it's not a quick fix, and it's definitely not a substitute for actually reducing emissions.
Right. Sounds like messing with these complex systems could backfire pretty badly. But, all this talk about international agreements and high-tech solutions, it kind of makes it feel like climate change is this huge problem that only governments and scientists can solve. What about regular people? What kind of things can we do in our everyday lives to make a difference? Where do we even begin?
One of the most impactful things you can do is change what you eat. Reducing your meat consumption, especially beef, can significantly lower your carbon footprint.
Yeah, I've heard that livestock, especially cows, are a big source of those greenhouse gas emissions.
Yep, it takes a ton of resources to produce meat, and the process releases a lot of methane. So eating less meat even just a couple of times a week, can really make a difference.
Makes sense.
Another big one is reducing waste. Think about it. Everything you buy, everything you use, it all has a carbon footprint.
Because of how it's made, transported, and then eventually thrown away.
Exactly. So the less we consume and the less we waste, the better.
It really makes you think twice about those impulse buys, doesn't it? What about those little eco-friendly habits, like using reusable bags, composting, all that stuff? Does that actually make a difference?
Every little bit helps. Those small changes, when enough people do them, they really add up. And speaking of making a difference, planting trees is a great way to take carbon out of the atmosphere and help biodiversity too.
I love planting trees. It's such a concrete action. You can actually see the positive impact growing over time.
Right. And it's not that hard to do.
It's really inspiring to hear about all these things we can do, in our own lives. But at the end of the day, climate change is a global problem, right? It's going to take everyone working together to solve it. What gives you hope that we can actually turn things around?
It's easy to get overwhelmed by how big this problem is, for sure. But I find hope in how creative and resilient humans can be. We've faced huge challenges before, and we've always found a way through.
Like we put a person on the moon? That seemed impossible back then.
Exactly. And with climate change, we already have a lot of the technology and solutions we need to create a more sustainable future. The real challenge is scaling those solutions up, making them happen quickly and fairly for everyone.
So it's not about inventing something totally new. It's about actually using what we already know and making sure everyone benefits.
Right. And we are seeing progress there. Renewable energy is becoming more common, more people are driving electric cars, and more businesses are setting these ambitious goals for sustainability. There's this growing understanding that dealing with climate change isn't just good for the planet, it's good for the economy too.
It's not just about saving the planet. It's about making a better future for everyone.
It's a chance to build a future we can all be proud of.
Wow, this has been an amazing deep dive into climate change. I'm feeling, well, a lot more informed, maybe a little overwhelmed by everything we've talked about, but definitely more hopeful knowing that there are solutions out there and that we can all be part of the change. Any final thoughts you want to leave our listeners with? Something to think about as they continue to learn about this issue?
We've talked a lot about solutions on a global scale, but remember, climate change is also a local issue. It affects different parts of the world in different ways, and the solutions will need to be different too. So here's a challenge for you. Take a look around your own community. What are the climate challenges you see? What are the opportunities? How can you contribute to making your own little corner of the world a better, more resilient place? Start small, think big, and remember, every action counts.
That's a great challenge. It makes it feel a lot more, well, manageable. We can all be more the solution right where we are. And that wraps up our deep dive into climate change. We hope you learned something new, that you're feeling a little more empowered and maybe even a bit optimistic about the future.
Knowledge is power, and taking action gives us hope. Go out there and make a difference.
Until next time, happy deep diving.